Greetings to every one of you. I am Dr. Raghavati, professor from Koga Engineering College. Now we will discuss about the ultrasonic imaging system. Ultrasonic imaging system is a non-invasive technique that uses a high frequency sound waves to generate an image. Frequency above the audible range is classified as ultrasonic frequency. Particularly for biomedical applications, it uses the range from 2 to 12 megahertz. And the transducer used is piezoelectric transducer, which works by the principle of piezoelectric effect. And here we will have a pulse generator. The incoming supply we will use power transformer, and that supply is given to the pulse generator, which generates high frequency pulses. And now when this high frequency pulse is given to the transducer, it causes the transducer to deform, which causes vibration, and it produces sound waves that passes through the patient. And once when it gets detected with an organ, it gets reflected back to the transducer. So thereby that sound wave, again the transducer undergoes a deformation, and which converts the sound waves back to an electrical signal. During that pulse, the switch is connected to this point, so the electric signal is given to the signal processor, which then displayed in the form of image in the display. And there are quite good number of applications in the biomedical field, namely neurology, the brain tumor, and in cardiology used to find the cross section of the heart and heart rate. Similarly, it is used for breast cancer diagnosis and in ophthalmology, etc. Now we will move on to the demonstration of how to acquire an ultrasound images, and this is which is powered by a 230 volt 50 Hz single phase supply. And here this is the probe, and there are three different types of probes. Here we are using the convex probe, and there will be a notch which we should hold at the left end of our hand, and this is connected through this cable. And we will have the high frequency transformer and the transducer. So when this pulse generator gives pulse to that transducer, the crystal gets a deformation, which converts that electrical signal into high frequency sound waves. So now we are going to test the heartbeat of a patient. Here we have volunteer Mr. Kabilan, one of my students, and this is the display unit and the keyboard. And normally any probe when we are placing on the patient, it has to be applied with gel to have smooth conductivity. So just I am applying this. Now we are going to measure the that is heart. We have the 4 chambers. Between the right auricle and the right ventricle we have the tricuspid wall, and between the left auricle and ventricle we have the mitral wall, that is bicuspid wall. So we will see that heart. Now we will see the demonstration of the ultrasound imaging system. And this is the ultrasound. There are 4 chambers in the heart, that is the right auricle and right ventricle. Between that we have the tricuspid wall, and between the left auricle and ventricle we have the mitral wall, that is bicuspid wall. Now we could observe the heartbeat, that is loved up sound. And here this is the tricuspid wall, which I am using the cursor to show this. This is the tricuspid wall heartbeat, and here this is the mitral wall. So thereby the transducer converts the electrical signal into sound waves, which is passing through the patient, and it hits the walls, and again it is reflected in the form of sound waves. That sound waves is converted into electrical signal. At that time the transducer undergoes crystal deformation, that is what we call it as inverse transducer effect, and that electrical signal is converted and displayed in the form of an image. This is all about the working of ultrasonic transducers in capturing the biomedical images, and thank you Mr. Kabilan for your cooperation, and thanks to all the students for watching. Thank you sir.